Find the equation of a line, a straight line, passing through -1, 5 and 3, -2. Right, so here we have 2 points. The equation of a straight line in gradient intercept form is y equals mx plus c. Now hopefully you know how to find it. Say if you can see the line, if you can see where it crosses the y-axis, and you can find the gradient by counting squares, something like that. Hopefully you can find the gradient if you can maybe draw a little triangle and work out the y step and the x step. You probably, if you know the gradient and you know 1 point on the line, hopefully you know how to do it by substitution. Here we kind of need to combine a couple of things because we have 2 points on the line. So right now, if I went to do a direct substitution to find c, I could pick either of those 2 points and I could call one of them x and one of them y, because remember this equation needs to work for every point on the line. So I could pick one, so I could have a y and I could have an x. Problem is I wouldn't have an m, so I'd have 2 things missing, and that's an issue. So what I'm going to do is find m using the equation that you absolutely need to know. M equals y2 minus y1 over x2 minus x1. So it doesn't really matter which point you pick as x1, y1 and x2, y2, but if I just write these down, so -1, 5 and 3 minus 2, I'm going to call this point 1, so x1, y1, and this point 2, x2, y2. If you did that the other way around, it would work fine as long as you got it right. The problem is if you start calling this, say, x1, y2. Now that isn't a good idea. It will only go one way, the wrong way. Right, so we need to find m. M equals, so y2 minus y1, -2 minus 5, -2 minus 5 over x2 minus x1, 3 minus -1, 3 minus -1. Well, -2 minus 5 is -7. 3 minus -1 is the same as 3 plus 1, which is 4. So it's a complicated gradient, but hopefully it'll be okay. Now, to find c, we can substitute any of these points. So whichever one looks easiest, there's not really much between it, but I'll just pick the first point in that case. Often, say one's got less negatives than the other, you'd probably select that, or maybe if one had a 0. In this case, there's really not a lot of difference. So y equals mx plus c. So at -1, 5. So at the point -1, 5, remember any set of coordinates is x, y. So I'm going to use this as my x, -1 will be my x, and 5 will be my y. We already know that m is -7 over 4. So y, 5, equals m -7 over 4 times x is -1 plus c. So actually that -1 did make it easier, because when you times -7 over 4 by -1, all this -1 is going to do is change the sign. So it's just going to become 7 over 4. 5 equals 7 over 4 plus c. Now, there's 2 ways of doing this. I would suggest one's probably easier, depending on your fraction skill and confidence. You need to get c on its own, so you could convert this to a fraction of fourths, which would be 20 over 4, but I think I would generally say to you, look, if you've got a nasty fraction bit in an equation, just multiply through by it. Multiply through by that denominator and it will give you a whole number thing to work with. So I'm just going to times everything by 4, which means everything. It means this and this and this. Just 3 terms, the 5, the 7 over 4 and the c. So 5 times 4 is 20. 7 over 4 times 4 is 7. It's 4 times 7 over 4, so the 4's disappear. C times 4 is 4c. So 4c is going to be 20 minus 7, which is 13. So 13 equals 4c. C must equal 13 over 4. just divide by 4. So finally, and it's not a very pretty equation, but it is the equation. Remember, y equals mx plus c, so y equals m minus 7 over 4, x plus c. C is positive, so plus 13 over 4. And that is it. That multiplying through bit, say this had been another number, if that had not been a minus 1, the time to multiply by 4 probably would have been there. Just a note worth saying. So whenever the first time this nasty fraction bit arises, that's the time when you need to think, should I multiply through by the denominator? And it generally makes things a lot easier.